Hi people, if you are watching this, then we have met again at the Twalumba Church Forum. Yes, I did promise that we will look at another video, and this time we may look at another subject, and this time we are practically actually looking at mathematics. Okay, so in mathematics we will look at one simple concept that is interrelated even in physics. For example, in physics, when we are dealing with the standard units, there are some values that we put, for example, omega and so on and so forth. Now when you look at those under scientific notation, you will note that you are actually dealing with powers, and hence it's very important that you understand the concept of powers so much, because it is very applicable in so many ways. The other thing is it will help us to deal with certain mathematics questions like this one here, which came in one paper in the year 2017, and this is Zambia. The other question is here. Now such concepts, such questions, we really just have to make sure that we don't miss marks in the exam. So this will help you, it will help us, and hence we start the topic of indices. Now what are indices? So for starters, we have to know indices. Now that's our topic for now. Indices. Indices are mathematical expressions or numbers which come in the form of A and B on top there. In this case, you will note that the A is the base and the B is the power. So mathematical concepts in this form are what we call indices. A is the base and B is the power. To work with indices, they have designed laws of indices, and if I just run you through those, you will note that you will be able to answer most of the questions on indices. So let me just title this one as law of indices, so that we can learn through certain laws. So laws of indices. Laws of indices. Okay. Laws of indices. So the indices have got laws, and the very first one we'll look at is a law that relates to multiplication. What happens when you are multiplying indices is very important. I'll run you through up to about 6 steps. Then 7th, we'll be looking at the powers and so on and so forth. Then we look at those sample questions I started with, we solve them and see if we have learned something. So we start number 1. So number 1, under the laws of indices, we're talking about multiplying. So we're talking about multiplying. Number 1, multiplying. And multiplying, when it comes to indices, we simply mean you add the powers. Very important to note. When we are multiplying indices, we add the powers. The powers, like I said, this is a power. Now you may be adding with another index which is also in the same form, so you should add this power to the other power. How do we do it? We have to make sure that first and foremost the base are the same variable, or the base are equal, they are not different. We're dealing with a mathematics concept in the form. I'll try to write formulas in red, then the work itself in black. Okay, so the mathematical formula is stating that if you are multiplying A to the power n multiplied by a to the power m, we should be as good as saying you get the base because it's the same, just one base, but you add n plus m, and what you get is the answer that we need. What you get is the answer that we need for this expression. Okay, let's work with numbers because people love numbers and maths is numbers. Let's say we have got the base of 4, for example. Let's say not. We have got 4 to the power 7. 4 to the power 7. Let me just make sure that it's a bit clearer. 4 to the power 7 multiplied by 4 to the power 3. According to our expression, we simply mean we are getting the 4 since it's common, but for the base, the 7 and the 3, we are adding them. This should be able to give us the correct answer of 4. 7 plus 3, we all know it's 10. This is well solved. That's what we mean, and that's the first law that we ran together under indices. When the bases are the same, then we can add the powers if the question says multiply this and that. Okay, we'll go to the other step. This is number 2. In number 2, we are dealing with a step that says dividing. Now, under dividing, the same concept of mathematics applies, but in this time, we will subtract the powers or minus the powers. That's what we'll do under dividing. Let me just write the expression which means dividing. Same concept, we say a the power n divided by a to the power m should be equals to a n minus m. Yes, so that is the expression if we are dividing, and it's very important. Now let's replace this one with numbers again, then we see that we are working so well. Okay, so we replace with numbers. We can start with the same numbers if we want. Okay, we can go with the okay, I'm liking 4 in this case. We can say 4 again. 4 to the power 8. Okay, not 4 to the power 8 divided by 4 to the power 2. This will be as good as saying the 4 is common, then we get the 8 power there, then we say minus, then we get the 2 there. Finally, what we have is 4 to the power 8 minus 2. The answer is 6, and that is the answer for that one. So basically, that's on a basic level. Let me try to just magnify on this one, this concept. What happens if the numbers, the base is the same, but we are dealing with a variable, and the variable itself has got different coefficients, and that becomes interesting. Okay, you can say multiplying again, different coefficients. You say different coefficient. Now, but the variable is the same. Different coefficient, same variable. Here we didn't have. Here we are dealing with numbers directly, but this time we want to include a variable which may be same but the coefficient being different. So we start. If we have got, for example, let's take this one, multiplying. We're multiplying. Let's say if we have got 4x to the power 2 multiplied by 3x to the power 5, we should be able to solve this one. The law will still apply, but only this time we will first of all deal with the coefficients alone. So we'll put coefficients in one bracket, the coefficient of 4 there, which multiplies with the coefficient of 3, but the variable is the same. Then we deal with the variable alone with the power, because the variable is the same. So we say, let me just make it clear. The variable of x, which is the same here and here, and we get 2. According to the law, it says multiply, so we are adding 2 plus 5. Then we close this one. This gives us what? Just this 4 multiplied by 3 is 12. Then the x is maintained. What is 2 plus 5? The answer is 7. And that is the way we deal with it when we have got different coefficients but the same variable and the powers are there. They may be different or same, but still we add if it's the powers, and that is solving it. So it is 12x times okay, I wanted to love that one. No, I'll leave it like that. 12x times 12x to the power 7. That becomes the answer for this one. And we're still in the basics, but I hope you are following up to this level and you are getting it right, because when you get these concepts, it means it will be more simple wherever we progress to. Okay, so that's how we deal with it. Under division, if it was dividing, we are going to do the same thing, but only that there we are going to use a minus in terms of the powers. Then we are going to find the correct answer, and that's how we work when we are dealing with coefficients which are different but the same variable in indices in mathematics. Okay. Then the next thing that we can look at just here is we go to the next step now. We want to look at the squared powers, or rather you're having a power and then in brackets squared with another power. So squared or power to another power. Okay, I can put this one as number 3. Okay, I still have the lab area. Okay. Number 3 squared powers. Number 3, then I call it squared. Okay. I'll sum it up by saying when you're having a power to another power, like power is raised to another power, a power is raised to another power. That's what we want to deal with right now. A power raised to another power. Okay, what do I mean? We're looking at an expression in the form of a to the power n, then to the power m. That's what I'm looking at. This we should be able to know that it should be equals to a to the power n, but just multiply the powers with the other power. the n and m will multiply, the coefficient maintained, then you would have solved that one. Okay, let's make it practical by introducing numbers in it. So we say not, but when we have 7x squared, 7x squared, then we introduce another power to this one. What are we talking about? 7x squared, then we introduce another power to this one. Let's start applying. First and foremost, this power squares the x squared, it squares the number also. It's very important, unless the number was not squared, but the number is squared also. So for the number also, we have to get the square of the number, and we can split this one by saying 7 is squared and x squared is also squared, like that. That's the meaning there. So what is 7 squared? We know we're talking about 7 times 7, which will give us 49, and x squared, we now apply this law. We have got x to the power and raised to another power, so we get the power that is raised to 2, then we multiply by the other power, which is 2. Then final answer, you will note that we are talking about this is 49 x to the power 2 times 2 is 4, and that should do it. That is the correct answer for this expression. So that is another law. When you are dealing with a number that is raised to another power, you handle it in this way and in this format. Okay. What else can we look at in the laws of indices? Let's go to point number 4, where we make things more interesting. We look at what if we have a situation where x is raised to the power 0. X is raised to the power 0. So let me start with the expression like I'm doing. If a number variable, is raised to the power 0, we should be able to know that the value of a is always 1. That is the meaning. If any number is raised to any power, or if any number is raised to the power 0, that number's value will reduce to just 1. You can have 100 to the power 0, the answer will still be 1. 12 to the power 0, the answer will be 1. That's the meaning. Even x, if x is raised to the power 0, is as good as 1. So 1 becomes the answer for this expression. So no matter what complicated numbers you have been given on this part, as long as the power itself says 0, then the value will be equated to 1, and that is the correct answer. Okay, then situation number 4, then we go to situation number 5. Situation number 5, what of the situation where our x or our number like a is raised to the power 1? What should we have? We should note that we will have the same number a. Any number raised to the power 1 will be equals to that same number. In other words, I'm saying if x is raised to the power 1, okay, let me write the power nicely. If x is raised to the power 1, then the value of this expression is simply x. And naturally, numbers the way they exist, they are to the power 1, only that we don't write the power 1. Just like we have a 1 in front of every variable which is just silent, we don't really just write like 1x to the power 1 again, no. So certain things are invisible, but if we were given a situation where x was raised to the power 1, then we evaluate it like that. We just say the correct answer is x. Any number raised to the power 0, remember, any number raised to the power 0 is 1, but any number raised to 1 is that same number. and those are very important. Let me give you step number 6 just here, and I want to work with I want to utilize this board fully. I don't want to consume more space. I'll put my point number 6 just there. I'll say if 0, however, just under this line, if 0 is raised to the power 0, and that's quite interesting. If 0 is raised to the power 0, if 0 is raised to the power 0, we should be able to know that this kind of mathematics expression is undefined. Undefined, or it gives us what we call maths error. If you placed this one on the calculator, it should be able to give you maths error. 0 to the power 0 is undefined. It's maths error. Okay, so that one we should note it, because we may want to say 0 to the power 0 is equals to 1, because any power raised to the power 0 is, any number raised to the power 0 is 1. No, so it's not applicable for 0 if 0 was raised to the power 0. That one we must have it in mind. Then we can look at something, let's say negative powers. Negative. I hope we are clear with the very first stages so far. When we look at negative powers, then it helps us to another level. What do we mean by negative power? Negative powers will be expressions in the form of, if A is a number, then it's raised to the power negative n. Now this, we should be able to know that we convert this one into a positive index, and it's very important that to convert this one into a positive index. How do we do that? We say 1, this one has come as a result of the negative, this one, then we say over, then we maintain the way it is, the expression. That was a to the power n. So that is how we work with this one. Let me go into examples on this one, then maybe it will be more clear, because when we apply, then we understand more. So I'll call this one example, because I have to look at 1 or 2. Example. So example for this part. Let me say example 1. If we have got 4 to the power negative 2, according to this expression of working in mathematics, we have said, we are simply saying, raise this one, change this one to a positive power. We start, change this one into a positive power, so we get the 1 there, then over the 4 to the power 2 as it is, 4 to the power 2. So that is the first step of solving this one. You first of all write it into a positive power or a positive index. After you write it into a positive index, the next thing, this is 1 over, what is 4 squared? 4 squared is 4 times 4, which is 16, and that is the correct answer. If you are given this index to be evaluated, then you would have done justice, you would have done the right thing. Okay, we go to example number 2, and we see what we can have here also. Let's assume we have got a situation where we have got 2 over 3. I've given you a fraction now, but this is dealing with a negative power. A negative power. So we start. First of all, remember we are converting it into a positive power. This time we'll just do something fast. What you do is you just swap these two. The 3 goes on top, the 2 goes down, then it is a positive power, but maintain the 2 just like that. So those are important to note. So we put the 3 there over the 2, we maintain the power. So we have swapped like that. The next, when we swap like this, we can simply raise this to this power and this to this power singularly. If you want, you can say this is as good as 3 squared over 2 squared. If you want, from just this stage, you can say 3 squared, 2 squared, still find it's the correct answer. So 3 squared is 9, because it's 3 times 3, over 2 squared is 4, that's 2 times 2, and that is the correct answer for that kind of mathematics expression. Okay, let's look at a case which is common in the exams, but we may mislead it and we may find it long, but we want to work with the problems so that we have things right. If you have got a case like 2x and raised to the negative power of 3, what will this be? Remember, when we were dealing with one example, I said everything in brackets. This example, I said the 7x squared is in brackets, meaning say it's raised to the power. Even the 7 is part of the numbers raised to the power. No wonder it was raised to 49 and the x to the power 4. Here we have not put the 2x in brackets, meaning say only the x is raised to the power. It's very important to note that one. So only the x is raised to the power, meaning that you can split this expression into only 2 multiplied by x to the power negative 3. When you reach this part, what comes next? We want to change this into a positive power, or positive index. You have 2 multiplied by this one. We have said it's 1 over that x to the power 3. Then you multiply this 2 and the 1 to give us 2 over x to the power 3. Very important, and that's how we solve that expression. So that's how we deal with the negative powers. I'm sure we have had a lot of ideas now on just how to handle negative powers. It's very important and it helps. Okay, we have looked at multiplying powers and so on. What should be remaining? Okay, I think this part of important, dividing powers. Let's just say dividing powers. This one is common for exams. Dividing powers. Dividing powers. Okay, what's coming up in the when we talk about dividing powers? So the expression we are looking at now is a to the power n divided by m. Okay, what do I mean? Let me write something parallel to it, which is same. It's as good as a n over m. If the power is a fraction like that one, then we mean it's dividing, the dividing powers. N over m, n over m. That's what we mean. Now, when you're dealing with this kind of expression, you should be able to know that this will be equals to, you introduce now the square symbol, or the symbol for the square root, this one. You put it there. Then this variable goes inside. It's very important. Or the number, the constant, and the variable goes inside. But these powers, the one which is on the base, comes on the outside there. The one which is down comes on the outside. Then the one which had raised this to the power, actually the one which is on top, you maintain it there. And that expression is the way we deal with negative powers. That's the way we deal with negative powers. Okay, let me just erase this n and write it nicely. Okay. Okay, so I need to write it nicely. And it's fine when, okay, it's now better. So like I'm saying, when you have an expression in the form an to the power a to the power n over m, it's as good as you get the base, put it outside, then the one which is on top, the number there, you put it, you leave it as the power. Then this will help us solve lots of questions in this formatting. It's very important to note, it helps. Okay, let's actually use this in examples, then it will help us. So we see what we are talking about. So we start examples and then we start solving examples. So the first example is a scenario where we say, if I've got 25 raised to the power half or 1 over 2, our formula states that you introduce the square root, right? They say solve for this one fully. So we say, our formula says you introduce the square root symbol, then you get the number which is on the base there, you put it there, then you get the 25 and raise it to the power which is there. So we say 25 to the power 1, which is just as good as 25 again, because 25 to the power 1 is still just 25, like we have learned. Now the next step is this symbol is for square root, the 2. If it was 3, it was going to be cube root. If it was 4, then multiply by 4. So just like that. So what is the square root of 25? We all know that it's positive plus or minus 5, but okay, I'll deal with just the positive part. We'll say 5 is the correct answer for this one. That is the square root of 25, and we have solved this one fully in our learning of indices, and that's nice. So this will pass through this stage, then it will become that, and that's the final answer. So far I'm sure things are clear for us, because I'm sure you are getting it. Okay, we go to another example. Let me make sure that the formula is visible. Okay, another example. X, if we have got 8 to the power 2 over 3, okay, let there be space between the two expressions. If we have got 8 to the power 2 over 3, how do we solve this one? Remember, we have said for numbers raised to the powers which are in form of a fraction, we introduce something like a square root or a square root symbol. Then we get the one which is on the base, put it there, so that becomes cube root now. Then 8, we still maintain it, but raise it to the same power, which is 2. When you have this scenario, the mathematics expression is being solved. You maintain the cube root. I love to split these into 8 times 8, which is easy for me. If you like that style, that's the one you can use also. Then we know that the cube root of just 1/8 is 2, because cube root means multiplying 3 times the same number, then you get that product. So if we say 2 times 2 times 2, you will know that 2 times 2 is 4, and then 4 times 2 is 8. Therefore the cube root is that one in this case, but we don't want to have everything on the board. Okay, so if the cube root is 2 in this case, then we are saying it's as good as saying the cube root of 8, 2, multiplied by the cube root of 8, 2, and the final answer is a 2 times 2, which gives us the answer 4. And that's how we deal with that mathematical problem we have solved that one. Okay, yes. What else should we look at under this as the best example? Okay, let's have a negative index but raised to the power, and we see how it works out. I'll work with 125 raised to the power 2 over 3. So 125 is raised to the power negative 2 over 3. It is a fraction, like I said, it's dividing, but it's a negative index. So what do we do first? First and foremost, start by making it into a positive index. So you say 1 over, then you get there 125, then you maintain it there, it is 2 over 3, like that. Next step is this one. Now apply the second law we have learned, which is the law of making it into something like a square. Then you get the 3 which is there, we put it there, the 125, and then you still raise it to the power 2. So that is the cube root. Okay, so for this one, let me follow it like this. You shouldn't be lost. We have gone this way this time. Okay, so 1 over, remember I said for me I split this, the cube root of 125 multiplied by 125. We have it like that. Okay, the cube root of 125, we are looking at a number that you can multiply 3 times to have 125, and there is no other number other than 5 itself. So 5 is the cube root of 125. 5 times 5, 25. 25 times 5, 125. Okay, so having known that, then we are saying equals to 1 over 25, which is the cube root. 1 over 5, we said 5 is the, so trying to prove it, that's what almost made me lost. Back on track. So 5 is the cube root multiplied by 5. Okay, so what is 5 times 5? 5 times 5 is 25. So we are having the 1 there over 5 times 5, 25, and that expression has been solved. So this one is just as easy as these steps, and then you would have found the correct answers. That's how we deal with the negative powers, and how we deal with the positive powers. I think so far, have we left out anything which is important? I believe not so much. I believe we have left not so much, but we have handled a lot. We have not left out much, I believe. Okay, since we have not left out much, I want to see, I'm assessing if we can now look at those questions, or maybe there is one concept that I've left which is quite very important, which can help us. Okay, negative powers. I think we have looked at everything. Maybe let me just end it by looking at just one simple concept. What if we have got an example, a question like this one? Solve. We are having a solve kind of equation, and we are dealing with a 2x raised to the power -3. Now from here we note that all of these have actually been raised to the same power, and like I said, it's very important. But first and foremost, turn it into a positive index, like I said. So it's 1 over, maintain the brackets, 2x raise it to the power 3. So the the 2 is being raised to the power 3, the x is being raised to the power 3, and that is as good as 1 over 2 to the power 3, which is 2 times 2 times 2, which is giving us 8. Then we have got x to the power 3. That is the way we evaluate or solve this expression. So indices, they are quite very interesting and they are very helpful. Go through this video at your own time. Again, you can play it back, just get these simple concepts. They will help you even as you learn more concepts of indices. Having reached this stage, I will try to help us look at these questions we have from the exam past papers, and I'll just solve on the actual papers. We see if it helps us. Okay, I'll screen grab so that I can write on the screen. We start. Okay, we have got evaluate 27 2 over 3. We said for this one, 27 2 over 3, it's just as good as, remember, it's a positive power, so we're just going direct to the square root. Then we get the 3 there, which is the cube root. Then we get the 27. Then we get the squared there. Then remember, I said for me, I like to split these 3, 27 multiplied by 27. So we now want the cube root of 27, because when we have the cube root of 27, we are as good as have solved this one. So the cube root of 27, what number can we multiply 3 times to get 27? Okay, let's start working it out. I start by working with 3. You can say 3 times 3 times 3. Is it workable? 3 times 3, that's 9. 9 times 3, yeah, 27. So we get it. So then this will give us the value to be 3 multiplied by 3, since it is the cube root of those numbers. We are having 3 times 3 is 9, so therefore 9 becomes the correct answer. That's what you write there, 9. Then you get yourself these 2 marks for this kind of an exam. So it's quite interesting and it's quite nice. So this one we have solved it, and that's the way we go. Okay, I'll save it for just reference. Save it. I'll call this one cube root CB. I'll call it cube root and save it just like that. Okay, can discard it. Okay, so this one we have solved it and it has helped us. Let's go to this one. This one looks complicated, but having learned all those laws of indices, you will note that it's actually even much simpler than it looks. Okay, I'll screen grab so that I can write on the screen again, then we start solving it. So first and foremost, for this expression, what should we do? The first part is tricky. That's 81 over 16. Then it's a negative power, 1 over 4. But this part is simple. 81 over 16. Why is this simple? Because the whole lot of this has been raised to the power 0. And from what we learned, we said anything raised to the power 0 is just 1. So the whole lot of this is equivalent to 1. But this, we make it a positive power. Remember what we did? We just swap this and this, then it's a positive power, but we maintain this one. So it will be 16 over 81. 16 over 81. Okay. Then 1 over 4. But plus the whole lot of this, we said raised to the power 0 is 1. That's it. Then when we have this stage, we deal with this separately. This one with this one with this. Okay, what do you mean? We mean this. You say 16 to the power 1 over 4 over 81 to the power 1 over 4 plus 1, just like that. Okay, we are still going. 16 1 over 4 there is more like you introduce the cube root symbol like we learned, or the square root. But this time we're dealing with 4 there, since 4 is the one which is down. Then 16 to the power 1, I'll just leave the 1 but then again square, or the fourth root, 81 to the power 1. Okay, this has become this. So we are looking for a number which when you multiply 4 times it gives you 16. Start with 2, which is the lowest, because that's what I've thought of. What about 2 times 2 times 2 times 2? 2 times 2 is 4, times 2 is 8, 8 times 2 is 16. So for the first part we are looking for a 2. So 2 is, okay, I add it just there first directly. 2 over, remember the 1, I've not forgotten it, we are still using it. It's plus, at the end of the day we add with the 1. So 2 over, what about 81? Let me try to work with 3 first. 3 times 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. Okay, let me work faster. 9 times 3 is 27, times another 3 is 81. So for the down part, 3 yes has it. So we say 3, but remember this plus 1, it was supposed to show there also. We are still adding with plus 1. Therefore mathematical expression has become as simple as 2 over 3 plus 1. When you're adding such, introduce the base there so that it's the same. Then how do we add fractions? We get the common denominator 3. 3 into 3, that's 1. 1 times 2 is 2, plus 1 into 3, that's 3. 3 times 1, 3. Then we add, we are having ourselves 5 over 3. Then you can leave it there, it's fine, but if you want a mixed fraction, then you can go 3 into 5, it's 1, it's remainder 2 over 3. Then you have solved fully. So the answer that was expected here is this one. Then you get yourself these 2 marks. And that's just how lovely mathematics is. Let me save this one also for reference as CR2. CR2 is CR2. CR2. Okay, I've saved. Okay, so that is how the indices work, and that's how applicable they are. They are a nice blend of mathematics, and they work so well. They work so well. They work so well. Okay, we use them especially in scientific notation and so on and so forth. But so far what we have learned is a lot. For now we can pause and say bye, and be ready to look out for expressions like 10 to the power x is equals to 0.1231. I've seen this one also on the paper. This one is also calling for your knowledge of indices, and this one is a scientific notation, so you take this back into the original form, then you can solve for this one. So you can solve this one even more faster. Let's say 10 to the power x, you move the point, and we know how to do that. So this is 1 2 3 4 5 we put another 0, so is equals to 10 to the power negative 5. Then when you reach, we moved 5 times, 1 2 3 4, then to put another 0, 5. When you reach this part, drop the bases which are equal, because the powers should be equal also. If the bases are equal, then we are having x, therefore x is equals to negative 5. So that's just how we deal with powers and so on and so forth. But the laws of indices are very applicable and they are quite interesting. They are actually what introduces the whole topic of calculus. If you understand these, you do well even in calculus. It was nice being with you. Remember, Mr. Halove, your teacher here. The lessons: revise to be wise, otherwise, likewise, you will not rise. So the Twarumba Jets Forum. Look out for more videos like this one where we just help each other in the sciences and the mathematics. Thank you very much for being patient and watching this video. I've really enjoyed just running with you. It's quite interesting, because what is a video at the end of the day if there is no audience to view it or to learn something about it? Remember, what you get, share also with your friends. Thank you very much.